You are welcome to my YouTube channel. My name is Alamiti Tilopadini, and we'll be looking at mapping and function. And the topic we want to look at under mapping and function today is what we term as what the composite function. And when we are talking of composite function, what are the things we need to note? We need to know that composite is denoted with what? With small letter O. And what is the meaning of composite function? Composite function simply means inserting the last function into the previous. Do we get it? That means you substitute your last function into the previous. And you need to note that when we have FOG, this means FOG. Your FOG simply means what? A function of what? Of G, of F of what? Of G of X. That means we are going to insert our G of X, which is the last function, into what? Our F of X. And also we can have GOF. And what is the GOF? It means a function of G into what? Into F of X. That means we are going to insert the F of X into G of X. But please note something. We need to know that our FOG is not the same as what? Our what? GOF. Now let's look at examples under composite function. Let's look at examples. We have if f of x is equals to 3x minus 5 and g of x is equals to x plus 2. They said we should find FOG and we should find the value of what? GOF. So how can we find FOG? We say FOG simply means what? F of what? Of G of x. That means we are going to insert our G of x inside F of x. So if we want to insert G of x inside F of x, that means anywhere we are seeing x inside F of x, we are going to put that x as what? As G of x. And that will give us 3 into x. So what is that x? Our x will now be what? Our G of x minus 5. And if we solve this, what do we have? We have it as 3x plus 6 minus 5. And this will give us 3x plus 1. And that is how we solve a composite function. It simply means you insert the last function into the previous. Now let's look at this. We are talking of GOF. What is the meaning of GOF? GOF simply means what? G of what? Of F of x. And if we are having this, what can we do? That means our GOF simply means what? We will insert our F of x inside G. So that means we are the major function is what? Is our G of x. That means anywhere we are saying x, that x simply means what? Our F of x. And we have it as x there. That will give us 3x minus 5 plus 2. And if we solve this, what do we have? We have it as 3x minus 3. Do we get that? It's simple. Now let's look at this again. We have if f of x is equals to x minus 5. And your g of x is equals to x squared plus 2. They say find GOF of x. And also, they said we should find GOF of what? Of 5. Now, what is the meaning of GOF of this and the GOF of that? So that means for this, we have to get the value of GOF first. For us to find GOF of x, that means we are going to get GOF. And what is GOF? GOF simply means what? Our G of what? Of F of x. That means what is the meaning? We are going to insert the F of x inside G. So that means anywhere you are seeing x inside G, you change that x to what? F of x. And what is your x there? We have it as what? X minus 5 all squared plus 2. And then if you now solve this, what do we have? Expand this, we have it as what? X squared minus what? Minus 10x plus 25 plus 2. And this will give us what? X squared minus 10x plus 27. It simply means you insert the last function into the first. Now they are not asking us to get GOF of what? Of 5. And don't forget, what is our GOF? Our GOF is what? Is x squared minus 10x plus 27. That means at x is equals to 5. That means insert your x as 5. What is 5 squared? That will give us 25. What is 10 times 5? That will give us 50 plus 27. And this will give us minus 25 plus 27. So what is minus 25 plus 27? That will give us what? 2. Now let's look at this last question to explain the meaning of what? Of a composite function. And this last question, I will be mixing three different functions together. We have if f of x is equals to x minus 5, and our g of x is equals to tan x, and our h of x is equals to exponential x. Now the first thing we are looking for is what? Is FOF. What is the meaning of FOF? FOF simply means our f of what? Of f of x. That means the same thing. What is the meaning of f of x? Anywhere you are seeing x inside f, you change that f to what? To f of x. And now we are having x here. So what is that x? The x itself is what? Is the f of x. And that means that x will give us x minus 5. Now since your x here is x minus 5, we are still having minus 5. That means this will give us what? X minus 10. Now let's look at this second thing. We are looking for FOG. What is the meaning of FOG? That will give us f of what? Of g of x. And what is the meaning of f of g of x? It simply means anywhere you are seeing x inside f, you change that x to what? To your g of x. And here we are seeing x there. And what is that x? That will give us what? Tan x minus 5. Now let's look at this. We are looking for GOF. What is the meaning of GOF? GOF simply means anywhere you are seeing x inside g, you change that x to what? To your f of x. And since we are having x here, that will give us what? Tan x. And what is that x? X minus 5. And without wasting time, let us look at this last example. Now that's number 4. We are looking for what? HOGOF. Wow! What is the meaning of this function? That will give us h of what? Of GOF. Do we get that? And what is the meaning of h of GOF? Mind you, we have gotten the value of GOF here. And what is the value of GOF? That will give us what? Tan what? X minus 5. So now, what is now the value, the expression for h of this bracket? That means you insert this function inside h. That means anywhere you are seeing x inside h, you insert that x as what? As that bracket. And this will now give us what? The exponential x. And that x is what? Is tan x minus 5. Do we get it? So that is a summary of what? Of composite function. It simply means you insert the last function inside what? The previous function. Now let's now look at the last and the least aspect of mapping. And the last and the least aspect of mapping is what we term as what? The continuous and discontinuous of a function. Wow. Now don't forget that last video we have looked at what? The meaning of what? Of limit. Now what is now the meaning of continuous and discontinuous of a function? We need to know that for a function to be continuous, it has to follow what? Some conditions. And what are the conditions? For a function to be continuous, a function is continuous as x is equals to a if it follows the following condition. And the following condition is for f of x to be defined at x is equals to a. That means the first thing is what? Your f of x must be defined at x is equals to a. And the second function is for us to limit our function to a. Do we get that? Your f of x must be defined at x is equals to a. The second thing is you limit your x of a, you limit your f of x to a. And now the third is now this: if your f of x is equals to when you are limiting, sorry, if your f of a is equals to when you are limiting your x to a, that means the function is what? Is continuous. And if they are not the same, that means the function is what? Is discontinuous. And we need to know that for a function to be continuous, it must be real or what? Or defined. That means if we are having an undefined answer, that makes the function to be discontinuous. Do we get that? So when we are talking of continuous and discontinuous, we said a function is continuous at x is equals to b if it follows some conditions. And what are the conditions? Your f of x must be defined at x is equals to a. That means we are going to substitute our x as a. And if it is defined, that means that is what our f of x is defined at x is equals to a. And also we are going to find the limit of f of x tending to a. And also, if your f of a is the same thing as when you are limiting your f of x to a, that makes the function to be continuous. But if they are not equal to each other, or when they are not defined, that makes the function not to be continuous. Now let's look at this question. And the question we want to look at is this. Number one, they said determine the continuity of f of x is equals to 2x minus 1 at x is equals to 1 over 2. Wow! So how can we solve this? Determine the continuity of this. That means for continuous and discontinuous, we need to get two things. And what is the first thing? You have to get your f of 2. That is when you are equating your f of x to what? To x is equals to a. That means what is your f of 2? That will give us 2 times x. And this will give us half minus 1. And what is 2 times this? We have it as 1 minus 1. What is 1 minus 1? We have it as 0. And also we have to find the limit of x tending to half of the function. And we have looked at limits. We said for limit is the same thing as when you are substituting. But the only thing pertaining to limit is if you can simplify a function, you simplify it before you insert. But this function we cannot simplify. So that means if you want to limit this, you just put your x to what? To half. And this will give us 1 minus 1 to give us 0. And from this, you can now see that your f of half is the same thing as what? As the limit of x tending to half of the function. So since these are the same, that means what? Our function, which is 2x minus 1, is continuous at x is equals to half. Do we get that? It's simple. They said determine the continuity of this. Find your f of x, find your limit of f of x of that function. And now we have looked for those two things. That means they are the same. So when they are the same, that makes the function to be continuous. Now, let's also look at some questions again. Now, let's look at this. We have if g of x is equals to x plus 1 over 2x minus 1 at x is equals to minus 1. Wow. They said we should find we should determine the continuity of this function. So if you want to determine the continuity of this function, that means we need to get two things. We need to get our f of g of what? Of minus 1. What is your g of minus 1? Put your x as minus 1. That will give us minus 1 plus 1 over 2 into minus 1 minus 1. And this will give us 0 over what? Minus 2 minus 1. That will give us 0 minus 3. What is 0 over minus 3? That will give us 0. It's not going to give us undivided. And also, we are now going to limit. We are going to limit our g of x. So if you want to limit our g of x, can we reduce this function? We cannot simplify this function. So since we cannot simplify this function, we are just going to insert our what? Our x inside. So that means the limiting of g of x tending to 1 will still give us minus 1 plus 1 over what? Minus 2 minus 1. Minus 2 in the sense that 2 times minus 1 will give us minus 2. And this will give us 0 over what? Minus 3. And what do we have? We have it as 0. And you can see that your g of minus 1 is the same thing as when you are limiting your g to what? To minus 1. And what is the conclusion? we can now conclude that what the function of g of x is what is continuous at x is equal to minus 1. Now under the continuous and discontinuous, let us look at this last question. Let's look at this function. Now we have a question here. They say show that f of x is equal to x squared minus 4 over x minus 2 is not continuous at x is equal to 2, but continuous at x is equal to 3. Wow. So how can we solve this? They said we should show that it is not continuous at x is equal to 2. That means for a function to be continuous or discontinuous, what are the things we need to get? The first thing for us to do is to get our f of 2. What is your f of 2? Put your 2 there. That will give us 2 squared minus 4 over 2 minus 2. And this will give us 4 minus 4 over what? Over 0. And this will give us 0 over 0. 0 over 0 is not 0. But 0 over 0 will give us what? An undivided answer. And also, if you want to limit our f of x to 2, that means this function we can simplify. And if you want to simplify this, this is a difference of 2 squared. And that will give us what? X minus 2 into what? Into x plus 2 over x minus 2. You know, difference of 2 squared. And that means this one we cancel this. And that will give us our f of x is equal to what? X plus 2. So since we have simplified for limit, we are now going to limit our x to 2. So if you limit your x to 2 here, what do we have? Our f of x will give us 4. And we have said it that if your f of x tending to 2 is not the same thing as when you are limiting your function to 2, that means the function is not continuous at that point. So that means since these two are not the same, that means this function is not continuous at x is equal to 2. Do we get it? Now let us test for s is equal to 3. How can you test for s is equal to 3? That means we have to get our f of 3. And what is f of 3? That will give us 3 squared minus 4 over what? 3 minus 2. And what is 3 squared? That will give us 9 minus 4 is 5. What is 3 minus 1? That will give us, 3 minus 3 is 1. And that will give us 5. That means when we are putting our x to 3 inside this function, we are going to find our f of 3 as what? As 5. Now, that means we are going to find the limit of that function tending to what? To 3. And we have said it that this function is what? Is a difference of 2 squared. And for limits, the first thing is for you to what? To simplify. And if you simplify this, your f of x will give us, this will cancel this, that will give us x plus 2. Now, what is now the limit of the function? When you limit this function, it will give us 3 plus 2 to be 5. And we can see that our f of 3 is the same thing as when we are limiting the function to 3. This is not the same. That makes them to be discontinuous. This and this are having the same answer. So since they are the same, that makes the function to be what? To be continuous. So therefore, we have shown that this function is not continuous at x is equal to 2, but it is continuous at x is equal to 3. Do we get it? And that is that about continuous. So let's now look at the last aspect under this. And the last thing we want to look at is the point of discontinuity. Now, the only thing we need to know concerning points of discontinuity is this. We need to know that what do we term as points of discontinuity? The point of discontinuity is the point at which we are equating our denominator to 0. That is the layman language, just for you not to cram. But you must know that the point of discontinuity is the point where your function is undivided. So that means the real terminology is what? Is undivided. And don't forget, if you are looking for the undivided of a function, what will you do? You equate your denominator to 0. And let's look at this question. They say find the point of discontinuity of the function. We have f of x is equals to x squared plus 4 over x minus 2 and x minus 1. We cannot simplify this. So what is the point of discontinuity? The point of discontinuity is the point where you are equating your denominator to 0. And if you equate this to 0, that will give us what? 2 and what? And 1. That means the point of discontinuity of that function will give us 1 and what? And 2. That means every other function will be real, excluding when your x is equals to 2 and 1. Don't forget, if you put your x to be 2 here, your denominator will give us 0. And anything over 0 will give us undivided. If you put your 1 here, this also will give us 0. Anything over 0 will give us what? Undivided. Now, let's now look at this. Find the point of discontinuity of this function. We have f of x is equals to 1 over x squared minus 4. Wow. So how can we solve this? Just equate your denominator to 0. And if you equate your denominator to 0, this is a difference of 2 squared. And that will give us x minus 2 and what? X plus 2 is equals to 0. And what is your x? 2 and what? And minus 2. That means the point of discontinuity is at where? At 2 and minus 2. So that is the end of mapping of function. Don't forget, we have released 3 videos of mapping of function. We released mapping of function 1, we released mapping of function 2, and also we released mapping of function 3. Please, I want you to know that all these videos are sequential. Don't jump to mapping of function 3 without looking at mapping of function 1. That means the first thing you have to look at is what? You watch mapping of function 1, you watch mapping of function 2, and you watch mapping of function 3. Thank you guys, and please, if this video has been impacting, please don't forget to click on that subscription button. I remain Salami Tite Lokwa Adeni. I love you.